We are doing the qualitative analysis of Lodacaine. First thing that you must do in this lab is actually put that in the test tube. And the very first test that we are going to run is the nihydrin test. And this tests for primary, secondary, and tertiary amines. So the very first thing I'm going to have is let my lab partner hold this test tube real quick. Can you please pass me a squirter bottle? No problem. Oh, it's right here for me. I'm sorry, I had it already. So, you want to get a little bit of squirt water? Oh, okay. Now, one of the things that you cannot do is put whatever you have remaining back into the main bottle. It will cross-contaminate and ruin your whole entire bottle. So I'm just going to throw this away. Make sure you remember that. Here you go.
Toss it in the trash.
Can you do a little bit of mixing?
No problem.
Let's do the next one.
There you go. So, do we see any results here? No.
Nothing visible.
No, nothing visible. So it is a negative test. Okay.
Alright, so I just added my lidocaine right now, and I'm about to add my forensic nihydrin. Fifth drop. Partner, you want to shake it up?
Why not? So it has appeared to dissolve, and it sustains the original color that the nihydrin carried. So to further test this, we will heat this in a distilled hydrogen bath, as long with this test of the bromine water. Now, remember what color it was originally. It was a lot darker than this, so obviously we are getting some type of chemical reaction since color did change. Now we'll keep this here and run some further tests.
Hold it back up. Right there.
Originally, it was some dark orange. We first thought it was positive, but now we know it's positive. So now we have our lidocaine, and we're about to dilute our bromine saturated with water. Like stir. See that, partner? Couple knocks.
Oh, yeah.
Really? So we have a positive.
So we have a negative test because it did not turn clear, which is quite surprising considering lidocaine does have an alkene. But we do further tests. Hello everyone, the very next test that we will perform is the HCl test with our product Lodacaine. Now, if you can please pour me some lidocaine in here, sir. Now, just to go through what we're about to do, we're going to get a test tube full of lidocaine, put some distilled ionized water so we can test the pH. It should be roughly around 7. And then what we will do is get another test tube, put lidocaine in it, and then fill that up with HCl. If it contains the nitrogen, the pH should be around the same range, about 7. If it does not, then the pH should drop to somewhere around 1 or 2, but it should be completely acidic compared to our deionized water. So if you could please put some deionized water in there, Thanks. If you could test our water sample.
So as you can see, it's looking color. closer to neutral. So it's about roughly probably 7 or 8.
Yeah.
Show that up for me one more time. And that's 8.
So it's around 8, which is a good indication that we do have nitrogen in our compound. So for comparison test, we will get some HCl and the original Lodacaine product that we were testing and see what the pH is around. And then we will compare the two. So, sir, can you please put some Lodacaine in that test tube for me? Thanks.
2 minutes.
Yeah.
No, we can't do that.
Yeah.
So you don't.
Here you go.
One drop of HCl.
Now we want it to completely dissolve, so we actually want more liquid in there than solid. So if you could please drop some more, sir. No problem. Thanks.
Now, to my lab partner here.
That's the stuff.
I had to add a little bit more. So now,
Is it completely dissolved? Now we're ready to test with our pH litmus paper. Please test this for me, sir.
no problem. Actually, I'm going to dump it right here in my load and check it.
The thing is, you have to test this without dumping in there because we have to retrieve it. So please test this for me, sir. No problem. Sport.
There you go. Stick it right in there.
Now, you could already see that some of the paper is already turning red once he tested it. Now,
Okay, there you go, sir. Alrighty. So now we have an acidic product inside, and as you can see, the pH level is about a pink color. pH level is under 7.
Let me see the pink color.
There you go.
Okay.
And it's under 4. There you go.
Okay.
Ready. So we have to say it's under 4, so we know that it's
hello everyone. Now we are at our next test, which is the Lucas reagent test, which tests if we have an hydroxide group in our compound. Now, considering that we have a Lodacaine compound, which has a benzene ring connected to a nitrogen group, connected to a tertiary nitrogen, we're not expecting any type of positive test for this situation. So, what I did to prepare for this test is add some Lodacaine in our test tube. Now, if my partner would be so kind to put some Lucas reagent in our test tube, we could further proceed with our test.
So, where's the Lucas reagent?
What is that, sir? It's right here. It is labeled Lucas reagent.
Thank you so much. My pipette.
That's what it's called.
Go. Alrighty. So I dropped our Lucas reagent inside of our Lodacaine. Give it a swirl.
Make sure you swirl it good.
No problem, partner.
No problem.
Alrighty.
Swirl it. I don't think you swirled it good. Swirl it better.
Alrighty. So we have our solid, and as we can see, it is not dissolving. There you go.
Which means it is a negative test. We do not have an hydroxide group.
Okay.
Now the very next test that we would do,
I'm going to need to see that
There you go.
in front of your face. There we go.
No problem.
Excellent.
negative, positive, negative.
Yes. It is
Positive.
negative.
Negative? Positive. I'm sorry, I don't get it right. It's not negative, positive.
So, at least we know that it's negative. Was I positive?
You were positive. You were positive. But you should have been negative about the test since it was negative. Just saying.
Alrighty. So.
Nice pun there.
Alrighty. You finished?
Yes.
So cameraman, if you come to the side to see where exactly our temperature range is at right now, we're starting at roughly around 34 degrees Celsius. Now we're going to increase this very slightly so that we get a very accurate measurement of where our melting point range is. So far we are at about 36 right now, and our product still is in the solid form. So we are still inside the...
Just a moment, let me see if I can get that.
See how that white shape is still there? We want that to be clear, and then that's when we can say that it is now a liquid. So until that happens, we're still have not reached the melting point.
And one thing to note, once the granules melt, make sure to know when it melted, when it started to melt, and when it became complete liquid, so you can get the range.
Right now it's still solid, so we're still waiting. So I'm going to increase these temperatures very slightly. Now, don't be impatient with this. The key thing to this test is patience. If you increase this to somewhere around 60 watts, it's going to be, the melting point is going to happen very quick, and you're not going to have a good range of where your melting started and when it became completely liquid. So your range is going to be off. So if you want to get an accurate range, you have to do this very slightly. So patience is a virtue.
See, my partner here is very, how can I say, very thirsty. So, I can say plenty of times he turned this up to about 70 to 80 volts, and it very much messed up our melting point. The error was, I'd say, per se, 10 to 20 degrees off. So, there was times where you actually have to make sure you keep watching this and know where you're at.
Alright, going.
Alrighty, so as we can see, it's starting to melt now. So,
Actually, that is completely melted.
okay, so if it's completely melted, then we know that at that certain rate, we have exact melting point.
Hold on.
Okay.
And go.
Now that we have identified when our solid was liquid, we have to see what range of temperature that was. Now we can see that it was around 66 degrees, around 66, 67.
So 66.4 was the actual melting point.
So yeah, we got it pretty close. We're off by 0.5 degrees, which is a good indication that we did the melting test right. Our very next test will be to run the NMR on our product Lodacaine. So what you have to do is just put a minute amount of your product Lodacaine into this beaker right here. Which I've done right here. And the very next thing we'll do is add some chloroform we add enough until it completely dissolves, which we have done right here. And then obviously you don't put this back in here because you would cross-contaminate that. We'll just do that right here, and then we'll throw that away. Okay, it seems like it has completely dissolved. So the very next thing we'll do is to prep it so we can put it into the NMR machine. So after we have dissolved our Lodacaine in chloroform, our very next step is to make sure to use some type of wool material, and so we can filter it out, so we make sure that we get anything that isn't dissolved out of there, because we can't put anything that isn't dissolved in the NMR because it will throw off the nuclear magnetic resonance. So what we would do is we'll put a piece of wool into our tube right here. Alright, that's how we have right here.
That's after we packed it down, correct?
Yes, sir. You can see right here, the wool is right there. We're going to use it as some type of filtration device. And this is the tube that we're actually going to put it into the NMR machine. So we'll put that in right here. next is to get the liquid.
You need a helping hand on that, partner?
Well, I would ask for your help, but the last time I did, it didn't end up, quite so well. So you can stay in the sidelines right there.
No problem. Alright, so does the liquid actually get to the level water boy? Or
it doesn't get to the level of water boy. It actually gets to the level of football player.
Oh, does it?
Yes.
Wow.
So once we run all the liquid into the filtration device that we have set up, we're actually going to put it into our NMR machine.
But first we need to put a top on it so that we don't lose any in the NMR machine.
Of course.
Cameraman.
You're welcome.
Of course.
I just wanted to make sure that you know that I gotta supervise this so that they don't screw everything up. Isn't that right?
Isn't that right, water boy?
All right.
We have to make sure
So now that we're going to do
Mr.
it,
BB is on point.
we're going to put it into the machine.
There's nothing in the machine, correct? That's right. That's what I'm here for.
So, when you first check that there isn't nothing in the machine, you actually find what you're looking for, which is this little particle right here. This is what's going to be used to hold our vessel.
All right.
Now, we're going to take some paper right here and make sure that you clean it just like this. Now, I have one quick question, guys.
What's up?
Is this supposed to be some type of yellowish color?
That depends
On what?
on the chemicals that you're using. Now you're going to want to put this on that, and then you're going to want to clean it again because you're going to size it on this to make sure that it is the proper distance.
Why is it yellow?
Actually, what you want to do is pull it down slightly.
That's what I was saying.
Yeah.
To size it on this.
Yeah. So go ahead and push it in like this.
This hand is Professor Bondurant.
Yeah, go ahead.
He is one of the professors of the school who make sure that we don't screw things up. And also we want to thank all the additional hands that show up, like our lab techs who brought us those really awesome batteries to keep this going.
So now, we put this in our NMR.
Yeah, you want to turn it this way, and then, yeah. Turn it halfway over and then the rest of the way.
Now, if you could please pass me that light apparatus.
Yeah.
Now, the whole point of checking this with the light is to see if it's spinning, which we
not.
can clearly see that it isn't. So we're gonna see what the trick is.
Put a glove on and you cover it. Here, go ahead and you can put it down again. That's fine. See if that fixes it.
Yeah, it is spinning now. So we're all good to go.
Take a quick look.
Yes, sir. It's spinning.
No, it isn't.
What's that?
It's crossed now.
Oh, yep. There's a cross. A little bit more.
Yeah, this is working again.
Sure, it's funny. It doesn't look like it's spinning, but it is. You don't see a cross on it.
Oh, okay. So the fact that you can see it, but you can't see the cross, it shows you that it's spinning because the cross means it is not spinning. So the invisible cross lets you know that the machine is working properly.
I see that?
I think it's good.
So now we are ready to check the machine.
Yeah. So shim it. Remember the command?
Yeah.
I'll tab first to the other screen. I always make that mistake.
So, the very first thing to run NMR is shim, enter. And you're going to do
5.
5. enter.
And when that box disappears, it's done.
The very next thing after the shipping process is completed is to press ZG, enter, enter. Then we will, while it's running the ZG, I will explain to you what we would do next after this process. Okay, so this is what our NMR is looking like right now.
Now, how did you get there?
Well, I got here using Alt-Tab after the ZG process.
Okay.
So the very next step to do is, you see this peak right here? This peak right here that I'm pointing at is our chloroform peak. So
That's this peak right here.
yes, this peak right here. So I'm going to have to cut that out. So this is our spectra out of the very first run. So there's a few areas that we have to adjust with this. You see this peak right here? This is our TMS. It is supposed to be at 0, but right now it is somewhere around 0.3, 0.4. We're going to take a closer look to see exactly where that's at. Okay, so we can see that our TMS is roughly around 3.41. It's supposed to be at 0, so we have to shift that to 0 so everything else gets shifted downfield as well. So we're going to accomplish this by going back to our original spectra, then pressing Alt-Tab, then we're going to press FO, enter, and we're going to put it at where the TMS was originally, which was 0.341. Enter. We want to put it at 0, so we'll put that 0. Enter. And we're going to press Alt-Tab again.
ZG.
And then we will press ZG.
No, on the other screen.
And then we will press ZG.
Enter.
Enter. And it's running the 0.
It's running the it's running the same thing.
It's running the same thing. The scan completed. Okay, so now we go to Alt-Tab again and see if we moved it. It did.
Let's go to it. Oh, yeah. Can't see anything.
You want to bring it?
Mind if I...
No, yeah.
Okay. Okay, so this is what happens after we have done the ZG. We actually zoned in for the portion of the NMR that we were looking for, and at this point, what are you doing?
I'm integrating.
You're integrating.
That's good, yes. Great.
Let me put this up.
And from the integration, we're printing so that we can have a sample of our product.
So, this is my handy lab partner. I give him much of the credit. This was a good session today. Cameraman, I appreciate it. Lab tech,
That's right.
you have any last words? This is our NMR. Oh shit.
Yeah.
This is our NMR.
Nice.
And this is the most powerful tool that we had for identifying what our compound was. We could have started with this and finished with this because it gives us all the information that we could have used to identify Lodacaine. Because no NMR for any compound is going to be similar. So we could have finished with this and started with this. So in order for us to give you a proper demonstration of how scientists work, we showed you the very first steps that scientists, without computer technology, used to identify compounds. And then we finished it with how modern day scientists use what they use to identify compounds, which is NMR and many spectra that they have at their disposal. Now this technique, I would say, is probably the most efficient. Now I would say NMR compared to IR is about the same, but me personally, I favor this because one, gives an instant gratification of everything you need right here. Functional groups, just by looking at this. On IR. For NMR, it's straightforward. So I say stick with NMR. It's better than this. Cameraman?
And that is exactly how we got our Lodacaine. Thank you. Have a good night.